Today we are going to be talking about complex numbers. Let's review where we are with our sets of numbers. We start off with natural numbers, which are sometimes called the counting numbers, 1, 2, 3, 4, 5. So from 1 to infinity, all the positive integers from 1 to infinity. Then if we add 0 to that, we get the set of whole numbers. Integers are all of those whole numbers plus all the negative whole numbers. So this would be the set of integers. Rational numbers. Rational numbers are a rational number is any number that can be written as a fraction where both the numerator and denominator are integers. So that includes terminating or repeating decimals. So these would be some examples of rational numbers. Irrational numbers is the set of non-repeating, non-terminating decimals. So square root of 3 is a non-repeating, non-terminating decimal. Pi, Euler's number E, and any other random, non-repeating, non-terminating decimal. Those are irrationals. If we combine all of those together, we get the set of real numbers, all rational and irrational numbers. So all of the above. Okay, what you may not be familiar with are these symbols that denote natural, whole, integer, rational, irrational, and real numbers. These are the symbols that denote those sets. I could not find this is correct that has that like double bar on the end. I couldn't find a font. I couldn't find it in my arsenal of different symbols. When I was typing this up, I couldn't find a W and I couldn't find an I, but those are supposed to also have the double bars on it, like that, kind of like that. But anyway, you get the idea. So there are those symbols. So it seems like this would be all-encompassing, that would be all we would need. But there is another set, and it's called the set of complex numbers. And it includes what we call imaginary numbers. So complex numbers are all reals plus all the imaginaries. So a definition of a complex number, by the way, okay, imaginary number I know you guys learned this in Algebra 2, but I is the square root of -1. That is by definition, that's what it is, the square root of -1. So a definition of a complex number is let A and B be real numbers. The number A plus BI is called a complex number. That's what the definition of a complex number is. A plus BI is called standard form. By the way, in class I will be telling you guys to highlight this. I will also be telling you to highlight what standard form is, because lots of times the directions will say write your answer in standard form, so your answer needs to be in this form. The first number is called the real part. The second number is called the imaginary part. When B is 0, then you just have a real number because there's no imaginary in the end. When B is not 0, the number is called imaginary. If A is 0 and B is not 0, so it would look something like that alone, like 2i, 3i, square root of 5i. When that's the case, your number is called a purely imaginary number. Okay, so this is a good visual of our number systems, our sets of numbers. The real numbers compose a lot, but the complex numbers compose everything. Okay. I wrote a little blurb up here because I always have students say, Miss Murray, are these really useful? And they are useful. You can read that. I'm not going to read it to you, but there are some real life, applications to complex numbers. In this course, where you're only going to learn the building blocks of complex numbers. Think of it as learning, I'm teaching you the letters of the alphabet. And then later, if it strikes your fancy, you might be using these building blocks to do bigger and better things with them. But right now, I'm just teaching you the very, very basics of complex numbers. Okay? All right. So let's talk about this. Let's go back. Oh, I need to plug in my computer. Hang tight. I don't want for my computer to go dead on us. Okay, there we go. All right, let's do some computations. So if I is the square root of -1, then we want to be able to do these powers. You know, what is I raised to some power? So I squared. If you square the square root of -1, you get -1 back. Okay? So the square of the square root of -1 is -1. Okay? Okay, let's take a look at I cubed. Well, I cubed is I times I times I. That's what I cubed means, right? So what I see there is, I see an I squared times I. Well, I squared we just said is -1. And -1 times I is -I. What about I to the fourth? Well, I to the fourth will be I times I times I times I. I have an I squared there and an I squared here. Both of those are -1. So -1 times -1 is 1. So I to the fourth is 1. What about I to the fifth? Well, I to the fifth is I times I times I times I times I. We just said that I to the fourth was 1, so let's group our I to the fourth together. Here's our 4 i's, that's I to the fourth, and that is 1. We have 1 times I, and 1 times I is I. Okay, I to the sixth. I times I times I times I times I times I is 6 i's, yeah? Okay, I to the fourth is 1, right? I squared is -1, and 1 times -1 is -1. So I to the sixth is -1. Okay, I to the seventh would be 7 i's multiplied together. Here are 4 of them grouped together, and when you multiply those together you get 1. Right? Here are 2 i's that I know I times I is -1, and we have a single I left. So -1 times I, this will be a -I. And then I to the eighth. Think I got that right? Okay, we have 8 i's being multiplied together, which is 2 sets of 4 i's being multiplied together. That would be I to the fourth squared. By the way, this would be I to the fourth squared, right? So this is just 1. And then we would start repeating again, right? I to the ninth would be back to -1, and so forth, okay? So one way to remember this pattern, I did not know this until a few years ago when a coworker said this is how she teaches it, and I loved it. My coworker, Miss Houston, was the one who first told me about this, the way she teaches the pattern for her students to remember it. And it's, think about what you would say if you won the lottery. If you won the lottery, you might say, I won, I won. Well, think of this as I won, I won. And then you just have to remember where to put your negatives. Your negatives are in the middle. So I is just I, and then you go I won, then put negatives in the middle. So I squared is negative 1, I cubed is negative I to the fourth is back to 1. So most of the time my students like that, but you can also think of it in this process too. So how would you find I to the 29th? I don't want to write out 29 i's, right? So I'm going to think to myself, okay, if I can just find how many sets of 4 i's there are, how many sets of 4 i's are there? If we take 29 and we divide it by 4, what do we get? Well, we get 7 with 1 left over. 7 with 1 left over, right? So this would be I to the 4th to the 7th. That would account for 28 of these, but you would still have 1 left over. So the I to the 4th to the 7th, that's just 1. And then you have 1 times I, which is I. Okay, so how many sets of 4 are in 95? I'm going to go off to the side, divide that out. 4 goes into 9 twice with 1 left over. 4 goes into 15 3 times with 3 left over. So that's 23 3/4. So this would be I to the 4th to the 23rd power times I cubed. What is I cubed? Well, 2 ways to think of it. You can think of I1. So that would be back to another I. It would be a negative I. I know that this thing is going to be a negative I. The other way you can think of it is this is 1. This is I squared times I, and I squared is negative 1. So that's a negative I. Okay. What about this monster? Well, 3781. Let's just see how many sets of 4 there are in there. 4 goes into 36 9 times with 1 left over. 9 times 4 is 36, so you have 1 left over. 4 goes into 18 4 times with 2 left over. 4 goes into 21 5 times with 1 left over. So this is going to be I to the 4th raised to the 945 power times a single I left over. This part is just a 1, so we just get I for that answer. So I to the 3,781 power is I. Okay. Alrighty, so that's how you raise your I to different powers. Well, what about other operations? We can do other operations. Performing addition, subtraction, and multiplication is rather intuitive. Okay, let's do a few examples. We'll learn by example. Okay, first of all, square root of negative 81. The important thing to remember here is always take out your I first. Before you do any operation, take out your I first. So this is the square root of 81 times I. Okay, and the square root of 81 is just 9. So that is 9i. Okay? What about this one? Well, this is going to be 5 times the square root of 12i. Take out your I first. Okay? And then we can simplify the square root of 12. The square root of 12 is 4 times 3. So that is the square root of 4 times the square root of 3i. And the square root of 4 is 2. And 2 times 4 is 10. Be careful. Make sure it is clear that your I is not under your radical. I like to put a little hook on my radical just to clarify that that I is not inside there with the 3. Okay? If there's a question, then I'm going to assume you don't know where the I goes. All right? If it's not clear and I'm grading your test, I'm not going to say, oh, they knew it was outside. I'm not going to do that. So you make sure you communicate your answers and communicate your work effectively. Okay, this next one. I see a power of I, so I want to reduce. I always reduce a power of I. I squared is negative 1. So this is already kind of simplified. I just need to write it in standard form. Standard form always has the real part first and then the imaginary part. So that would be my answer there. Okay. Adding two complex numbers together. Well, if you're adding two complex numbers together, we can just get rid of those parentheses. Oops. Adding the two together, just get rid of the parentheses and then add the real parts together. So 13 minus 5, and then add your imaginary parts together, and you're done. Okay? Subtracting, we just need to do one more step. So I'm not just going to remove those parentheses because I need to distribute this minus through those parentheses, and then combine my real parts, 3 minus 6, and my imaginary parts, 2i minus 13i, and I get my answer. So that's adding two complex numbers together, subtracting two complex numbers, multiplying two complex numbers. We're just going to FOIL this out, distribute it out. So 7 times 3 is 21. 7 times negative 5i is negative 35i. Negative 2i times 3 is negative 6i. Negative 2i times negative 5i is plus 10i squared. Again, I see an I squared, a power of I, that's negative 1. So this is 21 minus 10, right? In fact, for the sake of your notes, I will write that together. Negative 35i minus 6i is negative 41i. And then this would be a minus 10 back in the back. I squared will change this sign to make it a minus. So then we have 11 minus 41i, 21 minus 10. Okay? Squaring a binomial. When you square a binomial here, I square the first term, and then I add twice the product of these. Well, the product is negative 20i. 5 times negative 4i is negative 20i. Double that, and it'll be negative 40i. And then the square of the last is plus, because when you're squaring negative 4, you get a positive 16i squared. Okay? This is what you would get if I wrote it side by side and FOILed it out. Okay? Now you have the I squared, which changes that to a negative 16. I squared is a negative 1. And then 25 minus 16. And we get our answer. Okay? Number 8. Square root of negative 9. Before you do not multiply these numbers together first take out your i's. The square root of negative 9 is 3i. The square root of negative 16 is 4i. So this is 12i squared, which is negative 12. Okay? Number 9. I'm squaring another binomial, but I have the square root of negative 6 in here, so before I square that binomial, I'm going to go ahead and change that to i's. This is going to be 2 minus the square root of negative 6 is the square root of positive 6 times I. Okay? Okay, now it's a binomial squared. So I start with the first and I square that. The square of 2 is 4. Then I multiply these two together and double it. It's going to be a minus because of the minus in there. The product is 2 square root of 6, I. double that. When you multiply 2 square root of 6i times 2, you double it, you get 4 square root of 6i. And now we're squaring the last thing. Well, when I square a negative, I get a positive. And the square of the square root of 6 is just 6. And the square of I is I squared. That is going to change this to a negative 6. I squared is a negative 1. So we have negative 2 minus 4 square root of 6 I. 4 minus 6 is negative 2. Okay. Alrighty, dividing complex numbers. Dividing complex numbers is a little less intuitive. Okay, the easiest way to think of it when you're dividing a complex number by another complex number is that you're doing something to get rid of the complex part, the imaginary part of the divisor, the denominator. So you multiply the numerator and denominator by something that's going to make the denominator just a real number. Most of the time this involves multiplying by what we call the complex conjugate. And the complex conjugate, this is another something to highlight, the complex conjugate of a plus bi is a minus bi. Notice that the real part, the real part stays the same. The only thing that changes is the sign on the imaginary part of the complex number. When you multiply complex conjugates together, you lose the imaginary part, okay? And that's why we do it when we're dividing it. We don't want anything imaginary in the denominator. So a plus bi times a minus bi is a squared plus b squared. A squared plus b squared. Okay, let's do some examples. Number 10. Okay, I don't want imaginaries in the bottom, and I see an imaginary in the bottom. What can I multiply by to get rid of that imaginary in the bottom? Well, lots of times my students will say multiply by a negative 5i because there's a positive 5i there. And I would say to that, that is perfectly fine, and you can totally do that. In fact, let's do that. Let's multiply by a negative 5i over negative 5i. If I do that, so I'm multiplying by 1 there. You have to, whatever you multiply by on top, you have to multiply by on the bottom. I have this minus that's out in front here, so I'm going to leave it out in front. And I have 3 times a negative 5i, that's a negative 15i. And on the bottom, what do we have? I have a negative 25i squared. But that I squared changes just to a positive 25. So now we have a positive 25 on the bottom. And a negative times a negative is a positive, so I have 15i over positive 25. And then that reduces to, there's a 5 on top and a 5 on the bottom, so that reduces to 3 over 5i. Okay? Nothing wrong with that, but I do want to show you another way. We started with this. Since this is just a 5i, and it's not a 7 plus 5i or an 8 minus 5i, it's just a 5i. It's really just an I down there that's the problem. The only thing that's the problem is just that I. So I'm not going to multiply by 5i, negative 5i over negative 5i. I'm only going to multiply, sorry, there's something in my throat. I'm only going to multiply by I over I, because that will get rid of the imaginary part of the bottom of the denominator. So then we have here negative 3i, I move that negative up with the 3, okay, over 5i squared. Well, 5i squared is a negative 5, so that is 3/5 I. It just saves you some simplifying. If you multiply top and bottom by the least thing that you have to, it'll just save you some simplifying in the end. So for number 11, the first thing I see when I look at number 11 is I see all of these even numbers. Can we do anything with all those even numbers? Well, we sure can. If I factor out a 2 from the top, it'll reduce with this 2 on the bottom, and that will be 4 plus 8i over I. So all I did so far is to take a 2 out. Nothing wrong with that. Okay? Factor a 2 out and then reduce the 2's. Now I have an I in the bottom. I'm going to multiply by I over I, or you could multiply by negative I over negative I. Either way is fine. So up on the top, we'll have 4i plus 8i squared plus 8i squared. Well, I squared is that negative 1, right? So this is going to be a negative 8, all divided by I squared. And I squared is negative 1. So this is, if we're writing it in standard form, which they tell us to do, this is negative 8 over negative 1, that's just 8, minus, or plus, 4i over negative 1. So minus 4i over 1. Okay? That's that. Okay, so far we have not had to deal really with conjugates. But for number 13, we will have to deal with a conjugate because I have a full-blown, A is not 0 here, so I have a full-blown regular, a quote, regular complex number. Okay, that's not official. Okay, so I am going to multiply by the complex conjugate. So we keep the sign of the 2 and we change the sign of the 3. That's how you do the conjugates. Alrighty. Okay. 5i times 2 is, do you realize that 5i times 2 is going to leave us with an I? But when I go and do the back part, I'm not going to have an I left. I'm going to have 5i times negative 3i squared. I'm going to do that part first because that's my real part of this number. It's going to end up being my real part of the number. 5i times negative 3i. Well, I'd have negative 15i squared, but that's going to change the sign of that negative 15 and make it a positive 15. 5i times negative 3i is positive 15. And then I will have a plus 10i. So all I did was reverse that. I just reversed those two. Divided by, okay, on the bottom, when you multiply complex conjugates together, you multiply the first two together, that'll be a 4. The middle term will zero out. Remember, that's what happens when you multiply complex conjugates together. There's no I left. There's not going to be an I left. So you have a negative 6i and a positive 6i. They're gone. Then in the back you have a negative 9i squared. Negative 9i squared is plus 9. That's why you get a plus b squared in the back every time. So this is 15 over 13 plus 10 over 13i. Do you see the A plus BI form, standard form? If they say standard form, write it in standard form. Alrighty, number 14. Okay, another like full-blown complex number in the bottom. So what do we multiply by? What do we multiply top and bottom by? We leave the sign of the first thing alone, and we change the sign of the imaginary part. So leave the real part, change the imaginary part. Okie doke. Up on top, got to FOIL this out on top this time. 6 times negative 1 is negative 6. Okay, here's a 12i minus 7i. 12i minus 7i is 5i. And then you have a 14i squared. 14i squared will be a negative 14. Got our top done with. Okay. Down the bottom, we remember that these are complex conjugates. So the middle term is going to zero out. Negative 1 times negative 1 is 1. The middle term zeroes out. Negative 2i times 2i would be a negative 4i squared, but I squared is negative 1, so this will be a plus 4. When you're multiplying complex conjugates together, you should have only positive numbers down here. Okay, so let's write the real part first. Negative 6 minus 14 is negative 20, divided by 5. I better write this in 2 steps. Negative 20 plus 5i divided by 5. Okay? Negative 20 over 5 is negative 4, plus 5i over 5 is i. So negative 4 plus i. Remember, when you do this at the end, you're doing both of those like that. Make yourself a little heart. Okay? Alrighty, number 15. It's getting a little bit more complicated here. Alright, 2 fractions. Well, when you add or subtract 2 fractions, we need a common denominator. And our common denominator will be the product of these 2 denominators. I times 4 minus I. That'll be the common denominator. The first fraction, top and bottom, needs to be multiplied by the 4 minus I. So I'll have 1 plus I times 4 minus I there. Minus 3 times the I, because we need to multiply top and bottom by I over here. Yeah? Okay. Let's FOIL this guy out, and we'll have 1 times 4 is 4, minus I plus 4I. That's going to be plus 3I. Minus I squared, that's going to be a plus 1. Minus I squared plus 1. Okay, minus the 3I that was already there. And then on the bottom we have 4I minus I squared, that's another plus 1. Okay, so up on top the 3 i's have zeroed out and we just have 5 on top. And on the bottom, I'm going to rewrite this in standard form on the bottom and make it 1 plus 4i. We're not done yet because we still have an I in the bottom. We have not done anything to get rid of that I in the bottom. Now I'm going to multiply top and bottom by the conjugate, 1 minus 4i. Leave your real part alone and change the sign of the imaginary part. Okay? 5 times 1 is 5, minus 20i divided by, okay, 1 times 1 is 1, the middle term zeroes out, and then we have 4i times negative 4i. That'll be a plus 16. So this is 5 over 17 minus 20 over 17i. Okay, one more like this. Negative 2i all raised to the 6th. Okay, negative 2i all to the 6th. So this is negative 2 to the 6th times I to the 6th. Well, negative 2 to the 6th is positive because you have an even power and a negative value. So it's going to be positive, and 2 to the 6th is 64. And then I to the 6th. Well, I to the 6th is I to the 4th times I squared, right? I to the 4th is the 1, and I squared is negative 1. So this is 64 times negative 1, or negative 64. Okay, how might we use this in algebra? Find all solutions to this quadratic, okay, to this equation. When they say find all solutions, that means we're finding both real and imaginary. So we are not ruling out the possibility of there being an imaginary answer here, a complex number answer. So I think of two really good ways to solve this. I always when I see a quadratic like that, I try to factor it first. But I know I'm looking at this, I'm examining this, and I know I'm not going to be able to factor it. So I'm not going to be able to solve this by factoring. Factoring is one good way to solve a quadratic equation. Another good way is the quadratic formula. And then there's a third good way, and that's to complete the square. And I know your least favorite would be completing the square. However, I need you to learn how to complete the square for calculus. We complete the square to evaluate, we have to complete the square to evaluate some integrals. So I need you to know how to learn to complete the square and not be afraid of it. We will get there. All right, so I'm going to do this both ways. I'm going to do this, I can't factor, I'm going to do it using quadratic formula, and I'm going to do it by completing the square. I think I'll complete the square first. Okay, here's how to complete the square on this one. There's my equation, right? To complete the square, you write down the first two pieces but not the constant. So write down the first two pieces but not the constant yet. It'll come in just a second. Okay, to complete the square, you go to your b term, your middle term. Cut it in half and then square what you get when you cut it in half. So half of that squared. Well, half of 6 is 3 and 3 squared is 9. So I'm going to add 9. Half of 6 squared. Now I changed it. I had plus 10, now I have plus 9. That's not good. I have to add another 1 to keep it the same. Okay? I just completed the square. Was that hard? Absolutely not. That is not hard to do. Okay? Now factor that. That factors into, it's easy to factor because we know what we got there. We know what we did to get that 9. So this will always be half of this number. And then this plus 1, I'm just going to move to the other side. Okay? Now, square root both sides. And when you square root both sides, don't forget your plus or minus over here. So we have x plus 3 is equal to plus or minus square root of negative 1, which is I. And then x is negative 3 plus or minus I. And we're done. That's the completing the square method. Okay? And that method will always work. And I need you to know how to do that method for integration when we get into calculus. Alrighty, but I am going to show you quadratic formula as well. Many of my students say, I'll learn to complete the square when I get to calculus, when I have to. For right now, I'm just going to use quadratic formula. There are other reasons why we would complete the square in this course too. We will do that when we get into conics and stuff. Okay, quadratic formula. Here is your equation again. And to solve it, you have to use this formula that you memorized. Okay? And if you didn't memorize it, then go and complete the square. Okay? But I do have it memorized. This is crucial to the formula. Do not leave this part off. A lot of kids just jump into the rest of the formula and they forget what they're doing. You are finding a value of x. Just like we found values of x over here. Write x equals, okay? Negative b, so negative 6, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. That's the quadratic formula. So let's simplify this. This is the square root of 36 minus 40 all over 2. 36 minus 40 is negative 4. Alrighty. And then we'll have x is equal to negative 6 plus or minus the square root of negative 4 is 2i all over 2. And so x is, okay, whoops. Remember to do this part. Okay, negative 6 over 2 is negative 3 plus or minus I. Got the same answers? Yay? Okay. One was done by quadratic formula, one was done by completing the square. Okay? Alrighty, one more thing to mention before I leave you with our notes for complex numbers are graphing. I'd be remiss if I did not mention graphing complex numbers. This isn't really included in this book for some reason, and I really don't know why, but it is a good thing to know. Graphing complex numbers. The coordinate system below is called the complex plane. It looks a lot like your Cartesian plane, what you're used to in the real number plane. It looks a lot like it. A lot. The only thing that changes are your axes. It's no longer the x and the y axis. It's the real and imaginary axis. Okay? In the complex plane, the point that corresponds to this number is the point AB. So, I have some down here for us to graph. So, 3 plus 2i. 3 plus 2i, I'm going to go to the point, what I'm used to graphing as 3, 2. So, 3, 2, this is 3 plus 2i right there. Get it to where everything's on here. That is the point. That's my complex number A. It's how you graph that number. Okay? Negative 4 plus 5i. Negative 4 plus 5i. Negative 4 on the real axis, 5i on the imaginary axis. This is B. What if we just have 5i? There's no real part to it. The real part is 0. So 5i would be right up here, just 5 on the imaginary axis. What about if there's no imaginary part? If there's only a real part? Well, if there's only a real part, like negative 2 here, that's just the point negative 2. Think of that as the number line, the real number line. That would be D. 1 minus 5i is 1 on the real axis and negative 5 on the imaginary. So that is E. And then negative 3 minus 3i is negative 3 on the real, negative 3 on the imaginary, and that is how you graph complex numbers. Easy peasy. Okay, so that is that's our little notes on complex numbers.